This is the video solution for the what is special about the numbers strategy. Question 3. What's the value of that? Well, what's special about that question? What looks like it's not a coincidence is that that's repeated, so just take that as a common factor. So that's the answer to that. That's question 3. Now, question number 4. What's 743% of 50 plus 50% of 743? Well, what's special about that is that these are just reverses of each other. So I'm just going to see if anything, I'm going to now use the smaller and simpler strategy. 60% of, let's say, 20 plus 20% of 60. Let's see if anything nice happens there. 60% of 20, well 10% is 2, so 60% is 12. 20% of 60 would be 12. So the answer is 24. I can't see any magical patterns there. So why don't we just say 743% over 100 times 50 plus 50 over 100 times 743. That's 743 times 50 over 100 plus 743 times 50 over 100. So that is 2 of those. Oh, there we go. If you got 50 something, you add another 50 of it, you have 100 of it. So the answer is 743. That was question number 4. Question number 5. So we're given that 5p equals 9. 9. I'm not setting this out properly. 5 to the power of p equals 9. Just having trouble writing 9s here. Yeah. And then 9 to the power of q equals 12. 12 to the power of r equals 16. 16 to the power of s equals 20. And 20 to the power of t equals 25. Now what I'm noticing there is that each new piece of information uses an ingredient from the piece of information before. So that's what's special about the numbers. So why don't we write this one? So I'm going to work backwards here. 25 equals not 20 to the power of t, but 16s to the power of t. Which, by the way, is 16st equals 25. But now, instead of writing 16, so let's write 25. Instead of 16, I'm now going to write 12 to the power of r. Which means that 12rst equals 25. Now instead of writing 12, I'm going to write 9q. Then you multiply the powers. And now instead of writing 9, I'm going to write 5 to the power of p. So therefore 5 to the power of pqrst equals 25. So therefore pqrst must be 2, which is what they wanted. So the answer to the question is 2. So that's question number 5. Question number 6. A triangle is cut from the corner of a rectangle. The resulting pentagon has sides 8. Now this is a bit of experimental. It says it's not necessarily in that order, but let's just start maybe by putting a 20 there and a 13 there. Why don't we make the 8 there, the 10 there, and the 15 there. Now, can that make sense? If I complete that, that would be 7. This is an example of mucking around, and kind of by elimination, I'm just kind of mucking around. If something goes wrong, then I'll know that this cannot be the correct configuration. So is 7 squared plus 5 squared equal to 8 squared? It should be, if that's going to be a right angle triangle corner. So it's not. Now, I'm just wondering if I have time to muck around with all the possible orders. I think there's a fair few ways to put these around, so I'm not going to waste time doing that. And maybe I should just have another muck around, just to get my head fully in the groove. Let's try putting that there, that there, that there, that there, and that there. That will be 5. That will be 10. So is 10 squared plus 5 squared equal to 15 squared? No, it's definitely not. So this is definitely convincing me not to waste my time just mucking around. So that's the point of this strategy. I'm going to think, what's special about these numbers? Well, that's twice that, but that's not that special. I mean, it seems to me that the 20 being the longest side really does have to go there or there. If it used to be a rectangle, that will definitely be . But it's not true that the next biggest side has to go there, because that could be 15 and that could be 13, or that could be 13 and that could be 15. It just depends on the dimensions of the rectangle. What else? Just trying to think what's special about these numbers. And whatever these are going to have to be a difference. So just thinking about possible differences, that's a difference of 2, that's a difference of 7, that's a difference of 5, that's a difference of 10, that's a difference of 3, That's a difference of 5. Just trying to think what nice numbers could go there. We could have 3 squared. I mean, I guess what I'm thinking is that you want this. I'm just hoping that this is a nice Pythagoras question, you know, where it's a whole number situation. Things like this. 5 squared plus 12 squared equals 13 squared. Ah. That's it. Here we go. That's special because it's in this Pythagorean triple. They're special because their difference, that minus that, is 5, or 20 minus 15 is 5. So we've got our 13, we've got our 5. So hoping to get a 12 there. Okay, here's another possibility. Nope. Okay, so if you had an 8 there and a 20 there, that would be a 12. Just hoping I can get a 5 there somehow. Oh, there we go. Have that as a 15, and that as a 10, and that'll be a 5. So that now means that that's 13. So that therefore has to be the configuration of those measurements. I'll just tell you again what I did. I noticed, I was thinking this is Pythagoras. I knew there were special numbers for Pythagoras. Here are the 2 most classic examples, though there are others. Just by kind of scaling up these, so notice that I've doubled those. So these are kind of the main 2 ones that get used all the time. And then I figured that what was special about these was that these numbers either appear in that, or the differences between them appear in that. Why were differences useful? Because when you cut from one side of a rectangle to the other, if a bit is missing, then you can work out the lengths by subtraction. So 15 versus 10 explains why there's a 5 there. So anyway, what's the area of this? It's 15 times 20 minus half base times height. So half base times height is 6 times 5 minus 30. So that's 270 square units. Okay, question number 7. P, Q, R, S. It's an O. Given that that's X, that's 4, that's 10. That's 5, that's 4, that's 8. Now what's special about the numbers here? Well, I guess there's the fact that those are the same. Doesn't say anything else special about these. It doesn't say that's parallel to that. These aren't similar. No reason to think these are similar triangles. If that had been parallel to that, then they would be, because that would be equal to that, and that would be equal to that. But it doesn't say that they're similar. So what's special? Oh, here we go. It is the fact that that's equal to that. So therefore, if you flip that over, this will, if this one gets flipped kind of over like that, this, just show you what I mean. Just try and get a black pen. So that will land there, which means that, because this angle is the same as that angle, that 10 will now go like this. So there'll be a 5 stretch there, and then another 5 stretch there. And so that will be x. So I'm just going to copy out this diagram again. You can have a 5 there and a 5 there. You can have this is 8 and this is 4, and we want to know what this is. Well, I said I'm not allowed to use a calculator. If I could use a calculator, I could use the cosine rule to work out that angle. And then I could use the cosine rule again to find that one. But it's not very efficient to use the cosine rule, especially if you're not allowed to use a calculator. So what can I do? So just going to pause the video just to avoid having too much. I suppose I'm just going to have to use the cosine rules. Call that x. So cos x equals 4 squared plus 5 squared minus 8 squared all over 2 times 4 times 5. So cos x equals, well, that can't be right. There you can. That's 41 minus 64. 41 minus 64 is negative 23 over 40. Just thanks, Jake. So now go x squared equals, Jake went in the video.
You're going to keep him in?
Yeah, why not? Tell the Year 9s that there'd be a prize for whoever spotted Jake in the video. So I'll call that A, B, C, capital A. So x squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times cos x. We know what cos x is. X squared equals 4 squared plus 5 squared minus, that's 40, so that'll be plus 23. Oh, so there we go, x squared equals 16 plus 25 plus 23, which is 41 plus, wait on, oh, so that's supposed to be a 10. That's supposed to be a 10, so that's 46. Okay, so x squared equals 162, so x equals the square root of 162, which is the square root of 2 times the square root of 81, which is 9 root 2. So there we go, that's the answer.